Passing functions to Spark. I wanted to touch a little bit on this before we move further. This is important to understand as you begin to think about the business logic of your application. The design of Spark's API relies heavily on passing functions in the driver program to run on the cluster. When a job is executed, the Spark driver needs to tell its worker how to process the data. There are three methods that you can use to pass functions. The first method to do this is using an anonymous function syntax. You saw briefly what an anonymous function is in the first lesson. This is useful for short pieces of code. For example, here we define the anonymous function that takes in a particular parameter x of type int and add 1 to it. Essentially, anonymous functions are useful for a one-time use of the function. In other words, you don't need to explicitly define the function to use it. You define it as you go. Again, the left side of the right arrow are the parameters, or the arguments. The right side of the right arrow is the body of the function. Another method to pass functions around Spark is to use static methods in a global singleton object. This means that you can create a global object. In the example, it is the object myFunctions. Inside that object, you basically define the function func1. When the driver requires that function, it only needs to send out the object. The worker will be able to access it. In this case, when the driver sends out the instructions to the worker, it just has to send out the singleton object. It is possible to pass reference to a method in a class instance as opposed to a singleton object. This will require sending the object that contains the class along with the method. To avoid this, consider copying it to a local variable within the function instead of accessing externally. Example: say you have a field with the string hello. You want to avoid calling it directly inside a function as shown on the slide as x, right arrow, field plus x. Instead, assign it to a local variable so that the reference is passed along and not the entire object shown. Val field underscore equals this.field. For an example such as this, it may seem trivial, but imagine if the field object is not a simple text hello, but is something much larger, say a large log file. In that case, passing by reference will have greater value by saving a lot of storage by not having to pass the entire file. Back to our regularly scheduled program. At this point, you should know how to link dependencies with Spark and also know how to initialize the Spark context. Also touch a little bit on passing functions with Spark to give you a better view of how you can program your business logic. This course will not focus too much on how to program business logic, but there are examples available for you to see how it is done. The purpose is to show you how you can create application using a simple but effective example which demonstrates Spark's capabilities. Once you have the beginning of the application ready by creating the Spark context object, you can start to program in the business logic using Spark's API available in Scala, Java, or Python. You create the RDD from an external dataset or from an existing RDD. You use the transformations and actions to compute the business logic. You can take advantage of RDD's persistence, broadcast variables, and/or accumulators to improve the performance of your job. Here's a sample Scala application. You have your import statement. After the beginning of the object, you see that the Spark conf is created with the application name. Then a Spark context is created. The several lines of code after is creating the RDD from a text file and then performing the HDFS test on it to see how long the iteration through the file takes. Finally, at the end, you stop the Spark context by calling the stop function. Again, just a simple example to show you how you create a Spark application. You will get to practice this in the lab exercise. I mentioned that there are examples available which shows the various usage of Spark. Depending on your programming language preference, there are examples in all three languages that work with Spark. You can view the source code of the examples on the Spark website or within the Spark distribution itself. I provided some screenshots here to show you some of the examples available. On the slide, I also listed the steps to run these examples. To run Scala or Java examples, you would execute the run example script under the Spark's home/bin directory. So for example, to run the Spark Pi application, execute run example Spark Pi, where Spark Pi would be the name of the application. Substitute that with a different application name to run that other application. To run the sample Python applications, use the Spark Submit command and provide a path to the application.